Okay, in this example, example 4, this absolute value inequality is going to look very familiar. We already did this in example 1, but now we're going to solve this by graphing. And you'll notice when I wrote the word graphing, I put it in parentheses because I'm going to show you in another couple examples, I'm going to show you how to really solve by graphing by using the graphing calculator. So this is just kind of a graphing on paper. I use it as a check. But I'm going to talk, as I talk through it, you'll see why this is a very handy way to do it, because you won't have to flip your inequality back and forth, and I think a lot of students have trouble with the inequality. Okay, so to solve by graphing, what we are going to do with this equation is we are going to just rewrite it, absolute value 5 minus x, and we're going to make this equal to 2. Not greater than 2, equal to 2. And then we'll use the graphing part to solve the inequality. Everything else is going to look the same. Let's split this apart, because remember, everything inside could be positive or negative. So we have 5 minus x is equal to 2. We also have 5 minus x is equal to negative 2. Notice how I had no sign, this kind of sign here, to switch back and forth. I just had to worry about the right-hand side. Okay, so let's go ahead and solve this. I'll move just a tad quicker here because we've already done this with a different example. So that's negative 3. I can divide this by negative 1 like such. So x is equal to positive 3. Let's move over and do the right-hand side. Subtract 5 from both sides. That leaves us negative x is equal to negative 7. Divide both sides by negative 1. So we have x is equal to 7. Okay, so the 3 and the 7, those are the same solutions you got when you solved it symbolically. So that hasn't changed. The 3 and the 7 are still the same, but no sign flipping back and forth. We didn't have to worry about any of that. All right, now this is how we do it graphically, on paper graphically. So you might know that the absolute value equation, when I graph it, it's always a V. So absolute value equations, wherever they're graphed, they're always a V of some sort. So we have two things to graph here. We have the left-hand side. There's the left-hand side. It's going to be a V because it's an absolute value. The right-hand side is 2. Y equals 2. Y equals 2 is a horizontal line. So that's y equals 2. Oops. A little bit better there. Y equals 2. This absolute value up here, 5 minus x. Okay, so there's the two equations graphed. The absolute value is always a V, and y equals 2 is a horizontal line. I don't have any graph paper or grid. I didn't need to worry about that. This is more of just a sketch. But here's the interesting thing. Let's do this in a different color. Where these two pieces intersect, well, this is the point 3, and this is the point 7, because that's what we got when we solved symbolically, 3 and 7. Okay. Now, we're going to figure out the inequality part. So this says, let's say it in different words. This says the left-hand side greater than 2. This means all the things x can be, that when I put it inside the left-hand side, turns out to be greater than 2. Well, if this horizontal line right here represents y is 2, then anything above this would be greater than 2. Anything below that would be less than 2. Let's switch colors again. So that means that this part of the graph right here, I'm shading that in right there, that part of the graph and that part of the graph, those are pieces of the graph that represent when the absolute value function is greater than 2. So remember that this line continues way out here. This line continues way out here. If this is 7, then way out here is infinity. If this is 3, then way out here on the left is negative infinity. Now let's go ahead and write our solution in interval notations? Well, let's look at the left-hand side. This neon green represents the solution, and it would go, if I drew it, it would go on forever and ever and ever, and it would include values, x values from negative infinity up to 3. Always a parenthesis around negative infinity. There's a greater than symbol here, not an equal symbol, so that's a parenthesis. And then, let's go back to the screen again. So the right hand side, that would continue on way, way, way up here. So that tells me that the right hand side would go from 7 all the way up to infinity. Parenthesis around the infinity, parenthesis around the 7. That should be the same solution we got for example 1, but we did it graphically. And so you can do this as a check. Some of the advantages of doing it this way is I worked with my equal sign versus my inequality. I didn't have to worry about flipping that inequality back and forth. So students kind of like this method sometimes. Then when I drew my little mini picture and I did my shading in, that allowed me to then write my inequality. So another way to do the absolute value inequality equations.